What happened to Mars? It's a question that has captivated scientists and dreamers for decades. Billions of years ago, the red planet was likely a blue one, with rivers, lakes, and a thick atmosphere that might have supported life. Today, it's a frigid, barren desert. So where did all the water and air go? The leading theory is that Mars' protective magnetic shield vanished, leaving it vulnerable to the relentless solar wind, a stream of charged particles from the sun that has been sandblasting the planet's atmosphere into space for eons. Now, a groundbreaking mission is about to give us our first ever 3D look at this planetary crime scene. Get ready to explore the twin Voyagers of the ESCAPADE mission and how they will map Mars' invisible shield. Unlike Earth, with its powerful global magnetic field generated by a molten core, Mars lost its planetary shield somewhere between 3.9 and 4.1 billion years ago. Without this defense, the solar wind, which travels at supersonic speeds, slams directly into the Martian upper atmosphere. This collision literally knocks atmospheric gases out into space in a process called sputtering. But Mars isn't entirely defenseless. It has a ghost of a magnetosphere. Locked into the crust, mostly in the southern hemisphere, are fossilized pockets of magnetism, leftovers from its ancient global field. These magnetic bubbles create a bizarre, complex, and dynamic hybrid magnetosphere. It's a mix of an induced field, created by the solar wind interacting with the upper atmosphere, and these localized crustal fields. For years, we've tried to understand this complex system. NASA's MAVEN orbiter, which has been studying Mars since 2014, has done incredible work. MAVEN confirmed that the solar wind is a major culprit in atmospheric loss. But MAVEN is a lone detective. As a single spacecraft, it struggles to tell the full story. When it detects a change in the magnetosphere, it's hard to know. Is this a small, localized event or a global shift? Is the change happening in one specific place, or is the entire system fluctuating over time? Robert Lillis, the principal investigator for the ESCAPADE mission from UC Berkeley's Space Sciences Laboratory, puts it perfectly. He explains that with a single orbiter like MAVEN, you might measure the solar wind upstream, but then have to wait hours for the orbit to bring you into the atmosphere to see the effects. By then, it's too late. The solar weather has already propagated through the system in just a minute or two. To truly understand cause and effect, you need to be in two places at once. And that is exactly what the Escape and Plasma Acceleration and Dynamics Explorers mission, or ESCAPADE, is designed to do. For the first time ever, we are sending two identical spacecraft, nicknamed Blue and Gold, to orbit another planet in tandem. This is the game changer. By having two observers, scientists can create a stereo 3D view of the Martian magnetosphere. They can finally disentangle changes happening over space from changes happening over time. One spacecraft can measure the incoming solar wind, the cause, while the other simultaneously measures the atmospheric response, the effect. This dual spacecraft design is the key to unlocking the secrets of how Mars lost its atmosphere. The 11-month primary science mission is brilliantly designed, split into two unique campaigns to answer different questions. The first campaign, lasting 6 months, will see Blue and Gold flying in a string of pearls formation. They will trail each other in the same highly elliptical orbit, dipping as low as 160 kilometers above the surface and soaring out to 400 kilometers. The time delay between them will vary, from just a few minutes to about half an hour. Imagine two cars driving down the same bumpy road, one slightly behind the other. The first car can radio back about the potholes it's hitting, and the second car can see how the road has changed in the short time since. This formation is perfect for studying the rapid, gusty nature of the magnetosphere. As the solar wind buffets Mars, the twin spacecraft will pass through the same regions of space at slightly different times, allowing scientists to track fast-moving changes and see exactly how the system reacts to space weather in near real time. After the first 6 months, the twins separate for the final 5 months of the mission. In this second campaign, they'll enter different orbital planes. Blue will raise its farthest point, its apoapsis, to 10,000 kilometers, while Gold will lower its to 7,000 kilometers. Now, instead of one following the other, they will be sampling completely different regions of the magnetosphere at the exact same time. This provides the true 3D perspective. For example, Blue could be out in the solar wind, acting as a space weather buoy, measuring the incoming energy and particles. At the same moment, Gold could be deep within the magnetotail, the region stretching out behind Mars like a windsock, observing the atmospheric ions that are being stripped away. This spatial separation is crucial for mapping the large-scale structure of the magnetosphere and understanding how energy and particles are transported through the entire system, from the initial impact of the solar wind to the final escape of the atmosphere. So how will Blue and Gold actually make these measurements? Each identical spacecraft is equipped with a suite of 3 cutting-edge instruments designed to work together. First, there's EMAG, the ESCAPADE magnetometer. Provided by NASA's Goddard Space Flight Center, this instrument will measure the strength and direction of the magnetic fields. To get a clean reading, it's placed at the end of a 2-meter boom, away from any magnetic interference from the spacecraft itself. By combining data from both EMAG instruments, scientists will create a complete 3D map of the magnetic environment, showing how the solar wind's magnetic field drapes around the planet and interacts with those remnant crustal fields. Next up is EESA, the ESCAPADE Electrostatic Analyzer. Developed at UC Berkeley, EESA is essentially a particle counter. It will measure the energy and direction of suprathermal ions and electrons, the charged particles that are either escaping Mars or raining back down into its atmosphere. Gwen Hanley, a science team member, explains it simply. We'll know which direction the particles are going and what energies they have, which tells us if they're coming back to Mars or if they are able to leave Mars. This is how we'll directly measure the atmospheric leak. Finally, we have ELP, the ESCAPADE Langmuir probe. Built by Embry-Riddle Aeronautical University, this instrument will measure the properties of the cold, dense plasma in Mars' ionosphere. This region is the source reservoir for many of the escaping particles. The ELP will give us the density and temperature of this plasma, providing a complete picture of the crime scene from start to finish, from the solar wind energy input, through the magnetic pathways, to the atmospheric particles being energized and lost to space. What makes ESCAPADE even more remarkable is not just its science, but its philosophy. This is a new breed of planetary mission. It's part of NASA's SIMPLEx program, which stands for Small Innovative Missions for Planetary Exploration. The entire mission has a budget of less than $80 million. To put that in perspective, the MAVEN mission cost over $580 million for its primary phase. How is this possible? ESCAPADE achieves this incredible cost-effectiveness by having a very focused science scope, using instruments with high heritage designs, and embracing a streamlined development process with commercial partners. As Robert Lillis says, ESCAPADE represents a new way of doing things with much lower cost, more commercial involvement, and a somewhat higher risk tolerance. He notes that component reliability has improved so much that sending 2 spacecraft to Mars is now possible for about 1/10 of what it would have cost 15 years ago. The mission is a beautiful example of collaboration. UC Berkeley leads the science. Rocket Lab built the twin spacecraft on their versatile Photon platform. Advanced Space designed the mission's trajectory, and Blue Origin's New Glenn rocket will provide the launch. This agile, affordable model could democratize space exploration, allowing for more frequent and targeted missions to explore our solar system. ESCAPADE is also breaking new ground in how it gets to Mars. Most missions to the Red Planet are slaves to orbital mechanics. They have to launch within very narrow windows that open up every 26 months, when Earth and Mars are perfectly aligned for a direct, fuel-efficient trip called a Hohmann transfer. ESCAPADE is taking a different route, a more leisurely but much more flexible path. After launching from Cape Canaveral, Blue and Gold will first travel to a gravitationally stable point in space, called the Earth-Sun L2 Lagrange point. They'll hang out there for about a year, doing some bonus space weather science, before looping back towards Earth for a gravity assist maneuver. This slingshot will then propel them on their way to Mars. While this journey takes longer, it frees the mission from the tyranny of the 26-month launch window. This kind of flexibility will be invaluable for the future of sustained human presence on Mars, which will require a constant stream of cargo and crewed missions. Beyond solving the fundamental mystery of Mars climate change, ESCAPADE has a very practical goal: protecting future human explorers. Astronauts on the surface of Mars or in orbit will be exposed to dangerous solar radiation, especially during solar storms. The planet's thin atmosphere and weak magnetic field offer little protection. By mapping the Martian space weather environment in 3D, ESCAPADE will give us the data needed to forecast these storms. Robert Lillis emphasizes this point, saying, "We will be making the space weather measurements we need to understand the system well enough to forecast solar storms whose radiation could harm astronauts on the surface of Mars or in orbit." In essence, ESCAPADE will be creating the first Martian space weather forecast system, a critical tool for ensuring the safety of the first humans to call the Red Planet a temporary home. The twin ESCAPADE spacecraft, Blue and Gold, are ready. They are scheduled to lift off aboard a Blue Origin New Glenn rocket no earlier than November 9, 2025. After their year-long layover at the L2 point and an 11-month cruise to Mars, they will enter orbit around the Red Planet in September 2027. The 11-month primary science mission that follows promises to fundamentally reshape our understanding of our enigmatic neighbor. ESCAPADE is more than just another Mars mission. It's a testament to a new era of agile, collaborative, and cost-effective space exploration. By sending two Voyagers to work in concert, we will finally gain a three-dimensional understanding of the invisible forces that stripped Mars of its atmosphere and turned a potentially habitable world into a desert. The discoveries made by these twin explorers won't just tell us about Mars' past. They will actively help us build humanity's future as we prepare to take our next giant leap to the surface of the Red Planet.